It's a pleasure for me to participate in this 12th International Conference on Environmental Toxicology and Ecological Risk Assessment. I will present you some results of a research entitled Pyrethroid Exposure, Genotoxic Chronic Effects and Glutathione S-transferase GSTM1, GSTT1 in vector control workers of Bolivia. This research was done in a group of persons that works in control vectors in my country, and they are exposed to different kinds of pesticides. In this case, we know that pyrethroids, for example, are a class of insecticides in wide use globally. And the acute effects of pyrethroids poisoning are very well documented, but the possible chronic effects of exposure to low doses of these compounds are insufficiently described. So this was the problem we found in this group of persons, that they were exposed for a long time, chronically. To begin the research, we have to take into account different approaches in the research level: risk assessment and, of course, risk management. In the research, we have done the laboratory and field observations, information on extrapolation methods, field measurements, characterization of population. In the risk assessment, this corresponds to hazard identification, exposure dose response assessment, and exposure assessment. And these 3 points are constitute a risk characterization. In this level, we cannot have many possibilities to manage, but we can contribute to these points. Development of regulatory options, evaluation of public health, economical, social, political consequences of regulatory options, and the agency decisions and actions that the people in charge could do. In our research, we take a study group or study population that was divided in 2 groups. One was the exposed group with vector control workers in different cities of Bolivia, and this was a number of 160. Then we have excluded 4 persons that have a history of hospitalization due to pesticides poisoning. So we have 126 participating. And finally, the group of exposure participants was compound of 122. In this other hand, we had the controls, not exposed people, that we recruited were 91. We excluded 1 person that was first degree relative of vector control. So the final group of non-exposed was 90. These participants were 212 persons. We did a cross-sectional study, and the pesticide exposure was determined by a questionnaire. About the methods, we used blood samples. We took blood samples, and these samples were analyzed for comet assay and glycosylated hemoglobin, and for the GST's polymorphisms. And also we took another sample, buccal cells, for the micronucleus test. Here we can see some sampling oral mucosa cells and blood sampling. These methods that we used were different level of biomarkers. Effect biomarkers constituted by the micronucleus test in buccal cells and the COMET assay in blood cells. And the susceptibility biomarker was compounded by GST-M1, GST-T1 polymorphisms. And to look at the diabetes and pre-diabetes for the people, we measure the glycosylated hemoglobin. And of course, we analyze some subjective health status, analyzing 62 symptoms individually. About our results, here in this table we can see some description of demographic analysis for the both groups, exposed and controlled. Here we can see they were from different cities of Bolivia. They were from Cochabamba, Santa Cruz, and La Paz. And we can see that the most participated people were from Santa Cruz, with 45.9%. In relation with the family pathological history, we have some important data as the diabetes that we found in both groups. More or less 26% of the exposed, they have history of diabetes in the family, and in the controls 40%. And about the smoking habit, we can see that both groups were no smokers. So they have more or less 72% in exposed and 80% in the control group. About illicit drugs used, most of the people answered that they don't use the illicit drugs. And the consumption of coca tea or swimming the coca, we found that 80% of the exposed people, 65% of the exposed people used to consume tea, coca tea and swim. About the genotoxicity, we found that in the buccal cells, micronucleus say, we can see in these photographs normal cells, and here we can see micronucleated cell with several micronucleus. And in this table we can see the comparison of means of nuclear abnormalities in buccal epithelial cells between exposed and unexposed groups, because we didn't found any significant difference in micronucleus, but in this comparison of buccal epithelial cells abnormalities, we can see that karyorrhexis was high level in the exposed group with a p-value of 0.007, and so it's significantly statistical. About the COMET assay, we can see a normal cell and a COMET in a lymphocyte cell, and in this table we can see the different parameters we use with the COMET score software, the DNA percentage, tail moment, and moment olive. And in no one of these three parameters we found an significantly different value, but we can see some elevated values of the DNA percentage in exposed, and also in tail moment and in moment olive in relation with the controls. About the genetic susceptibility with the GST's polymorphisms, we found in the total population that 75% of the people were nulls for the GSTM1, and correlated with exposed and controls, we found that more or less the same number of people that has the null GSTM1 in exposed and in the controls. About the GST1, we found that 79% of the total population were null for the GST1. And comparing the exposed and the controls, we found that in exposed people, we found more high level of more people that has null the GST1, 71 people. In relation with the pre-diabetes, diabetes, and diabetes, we can see the prevalence percentage of the exposed is very high in relation with the controls groups. You can see, and we adjusted these values with 4 compounding factors like age, body mass index, smoking place, education level, family diabetes, and use of antidiabetics. And we found the same value. So the odds ratio of the controls related to the exposed was very high. And we made some other adjust with the people that use only pyrethroids, and we found a value more high of the odds ratio. And we can interpret it in this figure the dose-response relationship between exposure and diabetes and pre-diabetes within the exposed group. And you can see the tendency of all people included in this graph, and only pyrethroid use, we can see the dose-response relationship. And these results are from the analysis of some subjective health status based on dichotomous exposure. As I told before, we make some clinical evaluation about some status of 62 parameters, and we didn't find more significant differences in this analysis. So in conclusion, we can say that the pyrethroid exposure did not induce detectable levels of genotoxic damage by macronucleus test in buccal cells, and the same in the COMET assay. But in the oral cytoma analysis, we found cytotoxic damage in karyorrhexis parameter that was statistically significant in exposed in relation with the control group. The frequencies of the GSTM1 and GSTT1 polymorphisms were determined in all groups, and the effect of the GSTM1 and GSTT1 null genotypes on the micronucleus frequency and buccal cells show higher values in relation to the positive genotype, but these values were not with the statistical significance. Long-term exposure to pyrethroids was associated with prediabetes and poor subjective health status. The latter effect was especially clear for overall health. Cumulative symptoms, general symptoms as cardiovascular, dermatitis, nose, eyes, and musculoskeletal symptoms. Associations between exposure pyrethroids and prediabetes were seen and some subjective measures of health. And the pyrethroid seems associated with acute, but not with the chronic dermatitis. So this study underlines the importance and of the use of protection, wearing personal protective equipment while the people is spraying. Thank you very much for the attention. If you have some questions, you can write me to this email.